Okay, so today's video is about LeetCode daily problem. I'll be reading and solving this problem. So I have not solved it before, so let me quickly read the problem. Okay, so it looks to me at this. So the first intuition I have is do B BFS traversal around the water. Let's say this I do BFS like all neighboring cells for 0. I expand it and assign 1, and then all like I do for this, I do for that. And there might be the issue when I cannot if I, let's say, like in this case, so I expand 1 and then I expand this 0 to 1, and let's say there gonna be like cases when every time I expand to 1 I need to check that I expand to the next height. I need to check if it's not if it doesn't contradict the can the heights decrease? So they say any adjacent cells must have an absolute height difference at most 1. So can be the case when it's not possible to like do breadth first search and like expand it. Okay. let's say we have this let's say we have this board and we have a couple of cells, so 3 by 3 and then 0 on the edge. So I'll have to do 1, 1 and then 2, 2, 2 and then 1, 1. Okay, what if I have even better, let's say 0 here, and I have like 4 by 4 board. So 1, 1 here, 2, 2 here, and then it's gonna be 3, 3. Okay. If I do 0 here, what's gonna be? So neighboring cells should, like, the difference between neighboring cells should be maximum 1. What if it's not possible? Should I return? Okay, the difference at most 1. So they can have a 0 difference. So like this one is valid. 1, 1, 1, maybe 2, 2, 2, 2, and 3. 3, 3, 3, and then because of this one I cannot expand it. So there are like 2 options. Either expand this side or expand that side. So let's say we have like really tall matrix. Let's say we have this matrix. And I start for 4 cells, and then here 0, 0, here 1, 2, 2, 3, 4, and then 5. And let's say I start from this 1, 1, and 1, 1, and then I do 2, 2, and then here was it? So here I should use 2, also 2. Here let's say 3, 3, 3. Then 4, 4, 4, and then here 3. I wonder if there is a counterexample. So my idea is to add cells to the queue. Let's say add 0 and 0 to the queue, and then I'll add 1 and 1 to the queue, and then 1 and 1 here, and every time I add that, I either need I either need to check like if it's possible to add. So like here, and then I add 1 to the queue. I check if it's possible to add 2. And then check if it's possible to add 2 here. And then I check if it's possible to add 2 here. So there is a chicken and egg problem. So like this twos. So when I add the first 2 here, I need this one is basically empty kind of cell. So I add 2 and then I check like if neighboring cells the difference is dealt absolute difference is maximum 1. So I checked this 2 and 1 delta is 1, this 2 and 1 delta is 1, and then here I check, and here is like this is empty cell, and in this case, in case the neighboring cell is empty, shall I still add it? I assume yes. And because I do BFS, it will gradually fill up the matrix, and I'll keep adding like cells to a queue. So I'll say add 2s, and then here that 1, so I'm adding 2 here also, 2 and 2, and then I'll gradually I'll start like checking, like let's say I'll start with this 2. I check the neighbor, this one is filled, the next neighbor is not filled, and then when I place the new integer here 3, I need to check if it's a good position. So like neighbors full difference at maximum 1. I don't know, like let me just try to program that one. I feel that there might be some edge cases here and there. Let me check this problem. How is this the same? It doesn't look like the same. Okay. So let me go. So 4 and I equals 0, I less than. So int, let's say int rows equal is water length, and then int calls is water 0 dot length, and then I'll go for I from 0 to other than rows I plus plus, then for and j equals 0, j less than calls j plus plus, and then I check, I'll add the queue, and then I'm gonna be coordinates, and then I'm gonna be a queue equals new linked list, and then I'll offer if is water ij, then I'm gonna add that ij coordinate to the queue offer new int. I'll have that ij and then 0th level, and then I'll do else. I'll do if water ij just minus if it's water. Okay. If it's water equals 1, then queue offer, and then if it's water equals 0, then if it's water is equal 0, then I'm gonna assign -1, and then while queue not empty, I'll do queue.poll type here, and then I'll do int years equals new int, say -1 0, then 1 0, then 0 -1, and then 0 1, and then queue pool, and then I'm gonna check for int d equals 0, d less than years length, d plus, and then int next I equals p0 plus years d 0, and then int next j equals p1 plus years d 1, and next I need to check if next I less than 0 or next I greater equal rows, or next j is less than 0, or next j greater equal calls. I'll do the following. I'll do just continue, otherwise I need to check if next I if is water next I next j, if it's or is water next I next j not equal -1, if it's not equal, that it means that's already filled, and then I will check if I can place the higher ground there. So I need for the next I and next j, so target, int target gonna be target height gonna be p2 plus 1, and then I'm gonna check 4 and d2 equals 0, d2 less than dearest length, d2 plus plus, and then I'll have boolean can place higher length equals false or equals true. Can place h length, and then I'll do next int next I equals next I plus dearth d2 I, and then int next j gonna be next j plus dearest d2 so it was I 0 I1, so like 1, and then I need to check if if let's say again, if next I less than or equal less 0, or next I less greater than or equal rows, or next j less than 0, or next j greater or equal calls. I'll just continue, and then if math abs target h and then boolean can place slen, and then gonna be true, and then boolean can place low length equals also true, and then if math ups target height, so target height gonna be p1 p2 plus 1 minus or is water next I next j is equal -1 if the height of the is water next I next j is greater than 1, then can place h length gonna be false, and do the same if math ups just can place a same length, and then can place L length, and then I'm gonna check if I can place h length. I'm gonna do is water and I no, is water next I next j gonna be p2 plus 1, else if can place same length, this water gonna be the same, and then else is water gonna be -1, and then can place same length if lower length, and then I wanna throw runtime exception. Throw new runtime exception, and then here on unexpected unreachable state. And then I need also to add queue.offer new int ij. Okay, new int ij. So I can always instead of storing like additional heights in the queue, I can just use this, and then the height gonna be p0 p, and then target height gonna be target height gonna be if water, just height, that's called height, if water next I, and then next j. So I might be mistaken here. So like I guess I got lost a little bit. Like when I pass the height. So initial I have 0 height. Let me quickly think about this one. So initially 0 height, and I explore if I should assign the same 0 height for the neighboring cells. Now should I assign a higher height for the neighboring cells? So I check next I, next j, p0, and then I have current height equals is water I p0, and then p1, and then I check all the neighboring cells. Next I, next j, and check if they have themselves neighboring. Then I check the height gonna be this one. Can place h length true, can place s length same length, high, h means higher, s means same level, and l means lower length. And then I explore the kind of if I can place it. And then here, so height call it just H, and then H, and then here also H, and then here gonna be also H. Gonna be H plus 1, gonna be just H, and then gonna be H minus 1. And then in the end, I need to offer next I and next J. And then I need to return is water. Some kind of that's logic. So high level overview. Initially I have a queue and I start with this water cells, and those that are not water cells I mark them as -1, and those that are water cells I add them to the queue. And then I have this direction array that's gonna help me identify neighboring cells. And then while queue is not empty, I pull the current cell, I check its height, and then I check all the neighboring cells to the current one, and I verify if I can place that neighboring cell on a higher level. If not, I wanna place it on the same level, and if not, I'm gonna place it on a lower level. And then I check if this higher, if it's like higher placement is, if the placement of this higher length is possible by checking all the neighbors for the next I or for the next cell, and check if this condition holds, like all these neighbors should have like X difference, so that should be less or equal 1, or like, yeah, if it's greater than 1, then can place H and is equal false, same as here, and same as here. H minus 1 actually, minus is water, yeah. Okay, and then I'm gonna continue adding new cells to their continue adding new cells to the queue, and then if that cell is already filled, I'm gonna return just -1. Oh, not return -1, I'm just gonna continue. And in the end, I'm gonna return the same as water array. So let's check if it works. Nope, it doesn't. So initially, I outputted so is water 0, 1, 0, 0. So for unknown reason I start. Okay, is water, so I need to change it to 0. Is water equals 0. Yep. Okay, let me check what they have. Why it's not that efficient at all. Backward pass is valid cell. So let me check what they have for the hints. Set each water cell to be 0, the height of each cell limited by the closest water cell. Okay, perform the multi-source BFS with the water cells as the sources. What if I just gonna do this? Do I really need that this condition. Let's throw here also. No, I don't need this condition. It's too many checks here. Place. It's gonna be interesting to prove that like this condition is not required for like lowering the land level. Else, so a new runtime exception. Let's say something is wrong. Something is wrong. And then here, meet. Yeah, still performance is not that good. I wonder like what's their solution. Breadth first search. Mention dynamic programming. Space complexity time O by NN, O by NN, and here O by MN, so the same. So if I just gonna copy their approach for the BFS, will it be better? Meet. Yeah, it's better. Wonder what is that? Why that? So they have the same BFS queue. Queue is based on what? Linked list. And then layer. And they do that internal iteration. Check. Is valid cell. Is valid cell. What is valid cell? Okay, that's cell height. Height of the next neighbor. You don't need to check if it's valid because, like, so in this situation, yeah, so some checks can be skipped. So in this situation, they will just traverse level by level, and then the first traversal will fill up the neighboring cells for the first water tower, or like for the first water land, and the second traversal will fill up for the second one. So they don't need do they need really this queue? Let's figure out. Do they need that level? No, they need it. Why? Oh, because they identify the layer level. But if I add the queue and then add the, let's say, add 0 here. And then like the queue poll current cell. So current cell 2 plus 1. Two plus 1. And then I want to remove this one. Next layer. So I'm gonna like just store the height in a queue. Yeah, not that better. Even worse. It was before. It was 39 memory, and now it's like it's a little bit better like memory, but worse runtime. Yeah. So let's wrap up. I call it as a pass. I had a small error when I forgot to update the water cell from instead of like having it updated like to 0, I still had it like 1 as a marker for water length. So it's like small error, but other than that, I claim it as a pass. So I wanted to do a follow-up for this solution. So I had that solution, and it turns out that like many checks that I made, they are not very useful, they are redundant. So all this check can place H length, S length, and L length. I can just remove them and then use the use just the only single kind of update, and I'll make the current height if it's like valid, and if it's not filled, I will increase the height. We'll make it +1 to the current height of the current cell. And if I gonna run it and submit it, it's gonna be still kind of I guess it depends on the time when I run it. So it might be like here, like 68th percentile of the runtime, or it might be like much slower. Let's run it again. No, actually it's good. I guess I was looking at the previous solution percentile. So I'm having, okay, so that's it. I'm having second opinion that it's like now more like looks like a fail, because I did an error and I also didn't get that I can skip all these checks and the solution still will be valid, and then I can like skip extra like checks for the neighboring cell if it's like if the placement is great for the height, for the selected height. So yeah, I'll claim it as a fail in order to like improve in the future. So hope you enjoyed it.